Previously, we looked at the three general-purpose sets, and you saw how they sort their contents by keys. Well, there are three general-purpose maps. The maps work much the same way as the sets, except they have the added feature that they allow you to find elements based on a key. The names of the three map collections are analogous to the names of the three set collections. They even work very much like sets, but they do have some differences. It's that key thing. Being able to store and retrieve values by a key make things a bit different. The fundamentals are the same, but the interface is a bit different. Let me show you. This is an example that uses the first of the three, the hash map. The class definition of the hash map requires that you specify two types, the key and the value that you are actually storing. The key is separate from the value. The two are not in the same object as they were in sets. As you will see, all ordering and comparing is done on the key. The value just sort of tags along with it. Anyway, in this example, the key is defined as being an integer class type, and the value is a string. As you can see, the types don't have to relate to one another in any way. When you put a new entry in the map, you specify both the key and the value. In this example, 6 strings are inserted as values, and each one has an integer for a key. The integers must be unique. If you try to insert a duplicate key, it won't work. The original value will be replaced by the new value. This loop iterates through the keys and prints the values associated with each of them. The values method returns a simple collection containing only the values in the same order they appear in the map. And the for loop then extracts an iterator from that. The iterator places the value of the elements, the strings, in the string object, one for each time through the loop. The result is that the values are printed in the order in which the keys are stored in the map. Now this second loop iterates through the numeric values of the keys and displays the string for each one. So we have two loops. The first one reports in stored order, and the second one in key value order. Here's how it looks. The first loop outputs the values in completely random order. That is to be expected because this is a hash map, and the keys are stored according to their hash values, which for all practical purposes is completely random. The second loop uses the key values in order to read the values. So it's output in key order. Now this is a version of the same program but with a different type of map. This is a linked hash map, which means the keys are maintained in the order in which they are added to the collection. The same two loops are executed. The first one will reflect the order in which the keys are stored internally, and the second one will be in order according to the values of the keys. Now, here's how it looks. The first list is returned in linked order, that is, the order in which they were added to the collection. And the second list is again in the order of the value of the keys. This third example is the same program yet again, using a tree map collection. Exactly the same code is used to retrieve the values, first in internal order and second in the order of the key values. Here's the result. This time the two lists are in the same order because the internal order is also the numeric order of the keys. There are a number of other things you can do with ordering in maps. With a tree map, you can extract values for a range of keys, and you can quickly get the first and last keys. You can even specify your own comparator on the constructor, like you saw in the earlier lesson with tree sets, and it will be used instead of the default order. The next lesson is about queues and some destructive read operations.